about its construction and working. The single-phase induction motor converts electrical energy into mechanical energy. It consists of two parts, namely stator and a rotor. The stator is the stationary part of the motor. It has laminated sheets that are provided with holes. These holes are arranged in a way to hold the windings. The laminated sheets are used to reduce eddy current losses. The stator consists of the main winding via which a single-phase AC supply is given to it. This single-phase AC supply produces an alternating magnetic field in the main winding. This alternating magnetic field gets induced in the rotor by the principle of electromagnetic induction. The rotor now has a magnetic field. Now, according to Lorentz law, the electrical and magnetic field will develop a force by which the rotor must rotate. However, that does not happen. The alternating magnetic field produced in the rotor makes the rotor instead vibrate at a fixed position. The reason why this happens is explained by the double revolving field theory, which states that the alternating magnetic field is a sum of two equal and opposite rotating magnetic fields. The two magnetic fields, being equal in magnitude and opposite in direction, do not provide the effective torque for the rotation of the rotor. This is like holding a book from two ends and pulling it by yourself. The force applied by you is equal on both sides but opposite in direction, and hence the net result is zero movement. This problem is overcome by providing a starting torque to the motor. This is done by bringing in another magnetic field that will help induce the starting torque required for the movement of the rotor. This is achieved by adding another winding called the auxiliary winding, which is placed perpendicular to the main winding. The auxiliary winding is connected to an AC source and produces two magnetic fields like the main winding. Out of the two magnetic fields produced by the auxiliary winding, one pair of magnetic field being opposite to the main winding gets cancelled, while the other pair adds up to the magnetic field of the auxiliary winding, giving the required initial torque and making the rotor rotate in one direction. Now, even if the current in the auxiliary winding is cut off, the rotor will still rotate. Because it has the initial torque required for its motion, the auxiliary winding is cut off by a switch. A capacitor is connected in series with the auxiliary winding. This is done to keep the auxiliary winding at 90-degree phase difference from the main winding, which helps in achieving our aim to provide the starting torque to the motor. This is how a single-phase induction motor works.
We know that a number of appliances around us like fans, dishwashers, washing machines, etc. are powered by electricity and are run by motors. These motors are made such that they are easy to use and are cost efficient. Such is the single-phase induction motor. They are easy to use, cost efficient, and find their applications in a large number of home appliances.